The nucleus, part 1. Now let's start by a new chapter, that is the nucleus. We're going to talk about the constituents of the nucleus, its binding energy, and its stability. Let's start by the constituents of the nucleus. We know that the nucleus is the center of the atom. The nucleus is formed of protons and neutrons. The protons are represented here by the red ones. Each proton has a positive sign, since the proton is positively charged. Its charge is 1.602 times 10 exponent minus 19 coulombs. The mass of the proton is 1.67 times 10 exponent minus 27 kilograms. Also, we have the neutrons, which are the blue ones here. The neutron is neutral. It doesn't possess any electric charge. Its mass is 1.67 times 10 exponent minus 27 kilograms. When comparing both masses, we notice that the mass of a proton is slightly less than the mass of a neutron, or we say that they are practically equal. Each nucleus contains a certain number of protons, denoted as Z. Z is the number of protons. Z is the number of protons in the nucleus. We also call it the atomic number. The atomic number. N is the number of neutrons in the nucleus. In this nucleus, for example, we have 9 neutrons. Hence, N equals to 9. And we also have 6 protons, so Z equals to 6. The protons and neutrons are called nucleons. A proton is a nucleon. A neutron is a nucleon. The number of these nucleons is denoted as A. The number of nucleons, which is equal to the number of protons plus the number of neutrons in the nucleus. It is equal to the sum of the number of protons and the number of neutrons. We write A equals to Z plus N. This is the number of nucleons in the nucleus, or it is also called the mass number. The mass number. That is to say, it is the number of protons and neutrons. To each nucleus, we associate a symbol, XAZ. A is the mass number, Z is the atomic number. For example, carbon, 612. In the carbon nucleus, we have 6 protons and 12 nucleons. That is to say, we also have 6 neutrons. This is the symbol of the nucleus. The nucleus is also called the nuclide. Nuclide. We say the nuclide X or the nucleus X. Now, what is a chemical element? It is the set of nuclei that have the same Z. The chemical element is the set of nuclei that have the same Z. The nuclei that possess 8 protons form the oxygen element. When in nature we find a nucleus containing 8 protons, here or here, we say that this nucleus is part of the oxygen element. It is called oxygen. The nuclei that contain 6 protons form the carbon element. When we find here or here a nucleus containing 6 protons, we say that this nucleus is part of the carbon element. If here, for example, we find another nucleus containing 6 protons, it is also part of the carbon element. To each number Z, we associate a name for the nucleus. The nucleus containing 8 protons is called oxygen. A nucleus with 6 protons is called carbon nucleus. The nucleus containing 1 proton is the hydrogen. Now, what do we mean by isotopes? Isotopes are nuclei that have the same Z but different A. Take an example, O816, O817, O815. These nuclei form the oxygen element. All these nuclei are isotopes since they have the same Z but different A. Similarly, here we have 2 isotopes of the carbon element. 612, 614. Same Z, different A. Now we're going to define and explain the atomic mass unit. AMU, atomic mass unit, or simply U. We define such unit of mass since the masses of protons, neutrons, nuclei, the atoms are extremely small with respect to the SI unit of the mass, which is the kilogram. The mass of the proton is 1.67 times 10 exponent minus 27 kilograms. The mass of the electron is 9.1 times 10 exponent minus 31 kilograms. For that, we define a new unit called the atomic mass unit. This unit is defined as follows. It is equal to 1/12 of the mass of a carbon-12 atom. It is 1/12 of the mass of a carbon-12 atom. That is to say, we say that 1U equals to 1/12 of the mass of the carbon-12 atom. So we write 1/12 of the mass of the carbon-12 atom. How can we determine this? By convention, the mass of 1 mole of a carbon-12 atom, the mass of 1 mole of carbon-12 atom is 12 grams. The mass of 1 mole of carbon-12 this is the mass of 1 mole of carbon-12 atom. What is 1 mole of an atom equal to? 1 mole contains Na, or Avogadro's number, which is equal to 6.022 times 10 exponent 23 atoms. Each mole of the carbon-12 atom, contains a mass of 12 grams. So Na atoms of carbon-12 have a mass of 12 grams. we write Na atoms have a mass 12 grams. So for one atom, what is its mass? The mass of C12, carbon 12 atom, equals to 12 over Avogadro's number, multiplying 1 by 12 and dividing by Na. As a result, 1U equals to the mass of carbon 12 over 12. 1U equals to, replace this here, we obtain 1 over Na. Here, the unit is the gram. On this side, we have the gram. The answer should be in grams. 1 over 6.022 times 10 exponent 23. The answer is 1.6605 times 10 exponent minus 24 grams. When converting into kilograms, by multiplying by 10 exponent minus 3, we get that 1U equals to 1.6605 times 10 exponent minus 27 kilograms. Some small applications. What is the mass of a proton in the atomic mass unit? Or simply in U. The mass of the proton is 1.67 times 10 exponent minus 27 kilograms. We obtain 1.0073 U. So how did we get this number? 1U equals to 1.6605 times 10 exponent minus 27 kilograms. So we divide by 1.6605 times 10 exponent minus 27. This is the mass of the proton. It becomes 1.0073 U. The mass of a neutron is 1.0085 U. The mass of the electron becomes 5.48 times 10 exponent minus 4 U. We notice that the electron has a negligible mass compared to the mass of the proton and neutron. Since they are in the order of a unit, this is in the order of 10 exponent minus 4. The mass of a nucleus is 3.34 times 10 exponent minus 26 kilograms. Its mass in U is 20.1 U. We convert such number by dividing by 1.6605 times 10 exponent minus 27.